All right, let's look how we can apply our vast knowledge of adding and subtracting polynomials, okay? So here's our application problem. It says you're enlarging a 5-inch by 7-inch photo by a scale factor of x and mounting it on a mat. It says you want the mat to be twice as wide as the enlarged photo and 2 inches less than twice as high as the enlarged photo. Okay. The first thing it wants us to do is to draw a diagram that represents the described situation and to label dimensions. Okay. And then it wants us to write a model for the area of the mat around the photograph as a function of the scale factor. Okay. Well, let's take a look at this. Let's go back and do a little bit more reading, maybe some underlining. Okay. The original photo is 5 feet or 5-inch by 7-inch. Okay. I'm even going to mark this one up a little bit. This is 5 inches. Okay. This is 7 inches. Okay. That's our original picture. We'll mark that up just a little bit. Okay. So we're enlarging it by a scale factor of x. Okay. So we're enlarging it by a scale factor of x, and then we're going to mount it on a mat. Okay. We want the mat to be a couple things. Twice as wide as the enlarged photo and 2 inches less than twice as high as the enlarged photo. Okay. It wants us to draw this picture. So what I'm going to do, scroll down just a little bit. Okay, and I don't want to scroll down too much. All right, but let's draw this picture. Okay, so let's pretend that this is our original photo here. Okay, and this is the mat that's going to go on. That it's going to go on. Okay, again, that's not perfect. It doesn't really have to be, but that's okay. All right, so the first thing I'm going to write down is this is 5 inches. I'm not even going to write the inches part. I'm just going to write 5. Go back here. Okay, we're just going to write 5 and 7. Okay, so that's a good start. Now we're enlarging this photo by a scale factor of x. Okay, and so we'll maybe get back to that in just a second here. Okay, the next thing that we're going to do is let's look at maybe how big the mat is. So it says you want the mat to be twice as wide as the enlarged photo. Well, if the photo is 5 inches wide, that means we want this to be basically to be 10 inches. We want the mat to be 10 inches wide. Okay, and then it said that if we want the height of the photo should be 2 inches less than twice as high as the enlarged photo, right? So this would be, so twice of the height would be 14, okay? And then we would, after that, I guess we would subtract 2 from that, right? Okay, and so this is a good start for us, okay? As we kind of look at that picture and look what we actually have going on here, okay? Now the tricky part here is the fact that we're enlarging this by a scale factor of x. Okay, and so when we look at this, that means that each dimension is going to get the same, I guess, percentage larger. That's not totally correct. It's going to be be multiplied by the same number. So this is going to be 7x. This will be 5x. This will be 10x, and this will be 14x minus 2. Okay. And so that's kind of like the enlargement part that we're actually discussing, right? So there's a couple things that we should actually write down here, okay? And I'm going to write down area of photo. So the area of the photo, of the original photo, can actually be represented by 5x times 7x, okay? And the area of the mat can be represented by 10x multiplied by 14x minus 2. Okay? And so that's a really good start for us, okay? Now, we've kind of answered part A already. We've drawn the diagram, we've described the situation, we've labeled the dimensions, okay? But now we're going to write our verbal model. Okay, so the verbal model is going to work like this, right? We want to know basically what's the area of this shaded part that's actually left over. Okay, that's what we're really interested in. What's the area of this? Okay, well, if we have an expression for the area of the photo, which is a 5 by 7, and we just include the x's, okay, the area of the mat is represented by 10x times 14x minus 2, then we should be able to say that the area of the mat, or let's say area of leftover mat, okay, or that shaded region that I just drew in there, that's going to be equal to the area of the whole mat, or let's just call it we'll call it area of mat, and I'll call that like total, as like the total area. You can see kind of how the red corresponds there. Then we're just going to subtract the area of the photo. Okay, so if we were to set this up further, okay, we would basically say this. We'll say that the area is going to be equal to, and we'll plug in the numbers that we know. Okay, this is now going to be 10x times 14x minus 2 minus the area of the photo, which was 5x times 7x. Okay, and now we're just going to do a little bit of distributing here. So this is the area is going to be equal to, I'm going to call this now 140x squared, because it's 10 times 14, or 10x times 14x is 140x squared. Okay, we then have the 10x times the negative 2, which will give us negative 20x. Okay, and then from there we're going to subtract. Well, 5x times 7x is just going to give us minus 35x squared. Okay, and at this point, we're just going to go ahead and combine these like terms here. So we're going to combine these two, and our final simplified answer is going to be that our area of the mat that's actually left over after the photo is kind of over it is going to be 105x squared minus 20x. Okay, and that is going to be our final simplified answer. Okay, I know this is a challenging problem, but I also know you guys can actually handle it. Okay, we're going to make it our goal to be able to do challenging problems like this.